Hi friends, welcome to my channel. Today we will see how to configure a chassis cluster with the SRX device. So before we get started, I'll show you the configuration that I have in my ESXi server. So you can see here I have SRX1, SRX2 with the same configuration with respect to the network interface, and I have the first FG01 as client and FG02 as server to test my lab. So let me show you the configuration that I have here for SRX1. If you go ahead, edit the settings, you will be able to see that I have five NICs attached to the SRX1 device, and the same goes for the SRX2. Okay, so I'll just give you a brief about how to configure these parameters in ESXi because it is kind of hectic. So if you click on networking, these are my physical interfaces attached to the ESXi server. I am okay. So this is the virtual interfaces that I have created for my lab purpose. So let me just show you the settings. Um, For example, if you click on this, edit settings. So what I have done is uh, the NIC that I use for the control port and for the data port, I have it set as accept, accept, accept. So you should have this configuration for the control port and the fabric port. So you can see here I have multiple virtual switches created for a different purpose. Well, and these are the port groups that I've created for the lab purpose. So if you click on any of the port group, let's say port group control. So this was created for the control channel between the SRX1 and SRX2. So if you click on edit, well, you will see the same settings here. Accept, 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 or else if you have done the settings in virtual switch, then you can inherit those attributes here. Okay, so like I said, I have two SRX device with a similar NIC configuration, and make sure you know the port groups that you're creating. For example, here in this example, this is the port group. This is the control interface that is going to be assigned for SRX1 and SRX2. So data 0 is my port group created for the control channel. If we go to the configuration, then you should be able to see that I'm inheriting the attributes of virtual switch, which is data 0. So if you go to data 0, you will see that I have accept, accept, accept for all the three attributes here. Let me just explain you something about the SRX device. So different models will have different interfaces acting as a control channel, but then the fabric link, you can define whichever interface you want, to behave as a fabric port. So in this particular virtual SRX, so the operating system that runs on the virtual SRX takes gig 0/0/0 as the control channel, the control port on both the devices. So what I've done here is the very first interface that you see for the SRX1. is data zero. Like I said, the data zero is configured to accept the three attributes that I showed you earlier. So data zero is going to be my control channel. I'm sorry. Let me explain you one more time. So the virtual SRX will have three interfaces for different purposes in cluster chassis. One, the gig 0/0/0 will be used for the management of the device, individual management of each device, SRX1 and SRX2. Gig 0/0/1 will behave as a control channel on both the device. And then in my case, I have defined gig 0/0/2 to behave as a fabric port on both the device. So by default, the device is going to take the very first interface, which is gig 0/0/0, as the management interface, which will look something like FXP0. And the control port will look like FXP1. And the fabric port will look like FAP0 or FAB1 if you have redundant fab interfaces. Like I said, 0, 2, these are the three interfaces that will be consumed for the management of the device, control channel, and the data channel. 0, 2, HA control. The same configuration you will see here. 0, 2 control. So this is going to be the FXP0, which is my management interface. This is going to be FXP1, which is going to be the control channel between the two SRX device. And the third one, I have manually defined it as the fabric port between the two devices. So the topology looks like this: virtual SRX1, virtual SRX2. Here in my example, you will see control port as I guess I have defined it 0, but then it is supposed to be 1. Okay, and 2, well, you will have to define it manually, which port is going to act as a fab port or the data port. Well, make sure whatever port group you create for the control port and the fabric port, um, make sure you have the settings similar to something what I have here. I've used data zero switch, the name of the switch. I have inherited the switch property. I'll show you the switch property here. Accept. So you should basically have this configuration. And in many cases, you will have to, set the MTU as 9,000 because fragmentation is not, allowed on the fabric port or the data port or the control ports. So if in case you're facing any issue, you can go ahead and change the MTU value so that, you don't have any issues with the fragmentation. Okay, guys, let's get started with our actual scenario. So this is the client which is going to communicate to the server, and I have two SRX device, and I have two redundancy group created. One is the redundancy groups 1, other one is the redundancy group 2. So what basically happens is you can define Let me start from the scratch. Um, like I was telling, this is the interface which is connected to the SRX. And let me show you the SRX device configuration. Okay, this interface is connected to the upstream server. This interface is connected to the downstream client. Okay, so the very first time when you will have the SRX device configured in ESXi, you should basically log into the device and then delete the interface. You will have to execute this command and then make sure you execute this command also. And then if possible, you can, run. You basically have to run this command first to erase all the configuration on both the device. Okay, and then you have to delete the interface, and then you'll have to delete the security configuration. You should not have any configuration for any of the interfaces once you have the newly created VM, the virtual SRX. And then once you boot up the SRX device after deleting all those configuration, you will see something like, well, before doing that, you will have to, go to your CLI, and then so let's say you are on SRX 0. So this is the newly created virtual SRX VM that you have. You will have to erase all the configuration. You have to delete all the configuration with respect to any of the interfaces that you have. Okay, and then you have to basically enable the cluster chassis, and you have to define uh, the role of that particular node. So in my case, SRX will behave as node 0. So you will have to execute this command. And then on the other end, SRX2, you will have to, delete all the configuration and then execute this particular command. Set set chassis cluster ID 1 node 1 on SRX2 on node 0 on SRX1. So what will happen is basically, so once you execute this command, set chassis cluster ID 1 node 0 reboot, it is going to, take the chassis cluster configuration, and then it is going to reboot the device once you execute this command. And the same goes for the other SRX2 device. Okay, so once it reboots the virtual SRX VMs, SRX01, SRX02, you should be able to see something like, well, this depends from device to device. In my case, you will not see the interface gig 0/0/0. Like I said, that 0/0/0 will behave as a management port to manage the SRX01 and SRX02 individually. In my case, it is FXP0. You can see here FXP0. I have configured the IP 192.168.11600, which is for the management. FXP1 is, well, the control link between the two devices. And this is my fabric port. the data port between the two devices. And the naming conventions for the interfaces would be something like this. So in my case, the very first interface 000 is used as FXP 0, which is for management of the device. So second interface 001 is used for the control port, which is going to be FXP1. So that is the reason why you are not able to see that. And then the third interface, gig 002, is going to act as a fabric port. And then the interfaces will look like this: 000 on SRX01, which is node 0, and 7/0/3 on SRX02. So this changes from device to device. You might have 4/0/3 for the SRX2 and 0/0/2 or 0/0/3 for SRX1. Once you have that settings, you will have to manually define which interface is going to be the fabric port or the data port. So in my case, you can see here I have defined the port, set interface fab0 fabric option, member interface gig 0/0/2, and fab interface fab1. Well, fab0 is the interface on SRX1. Fab1 is the interface on SRX2. Don't confuse yourself with FXP0, FXP1. Well, the naming convention for the fabric port or the data port is like FAB0 on the first SRX device and Fab1 on second SRX device. So whenever you configure the fabric port, you have to use this naming convention: 0 for SRX1, 1 for SRX2. You can see here. And then you can see here, my control link is up and my fabric link is also up, and my fab link on SRX1 is 2702 on SRX2. Well, to individually manage the two devices, like I said, you already have a dedicated port, which is the very first interface, gig 000. So, so in order to do that configuration, well, you will have to, define the group name for each of the devices that you see. So in my case, I have set the group name for node 0 as SRX01 and for the SRX2 as 02. And then similarly, set group node group 0 interface FXB0, and then I've assigned the address here. And similarly, I have assigned for node 1. And then you have to execute this command, which basically applies this configuration to the respective SRX device. In my case, it is going to be node 0 and node 1. And then once you are done with that, once your fabric link is up, if you can check the interface status here, whether the fabric link is up or not. Once it is up, then you can create the redundancy group. This is, well, different objects that you create. So this is the object which will have multiple network objects attached to it. So in my case, I have created multiple redundancy group. Well, failover of redundancy group is independent of the failover of cluster chassis in this particular scenario. So don't confuse yourself with the chassis cluster and the redundancy group. Well, redundancy group is actually a virtual group where um, where you attach your network objects to that redundancy group. In my case, you will have to set the red count. So I have defined that I'm going to use two red interfaces, redundant Ethernet interfaces, like you can see here. Red is nothing but the aggregation of the interfaces on node 0 and node 1. You can see here. So set interface, this is the node 1's interface. I'm going to set it for red 1. And similarly, the same interface, which is having the different naming convention on node 2, which is SRX2, I'm going to define it to the same red 1. So it is aggregate of both the interfaces on each devices, red 1. You can see here. And then once you have created red 1 and red 0, you can define it to a redundancy group. Well, in my case, I have given red 0 to group 1. Well, here I think I have mistyped it. Well, this is red 1. Defined to group 2, and red 0 defined to group 1. And you can decide on which particular node this redundant group is going to be active by setting the priority. You can see here I have created two redundant group. There is going to be a redundant group 0 already defined by the code. Well, you can also use that redundant group, but then for your configuration, custom configuration, you can create multiple redundant group. In my case, I've created two, and I have set the priority for node 0 high, and for group 2, I've set the priority for node 0 100, node 1 200. So in my case, RG1 is going to be active on node 0 and RG2 is going to be active on node 1. Well, what it's going to do, it is going to load share your share. It is going to, load balance your traffic. So the incoming traffic will come on to node 0, but then the outgoing traffic will go out via node 1. And the traffic from node 0 to node 1 will go through the fab port that you have just defined, which is 002 on both the devices. That is where the fabric port will come into picture. So if you want to see the status of that particular RG group, you can see it here. So this is the default redundant group, and this will fail only if the routing engine on the node 0 will fail. Okay, because I started the SRX2 first, that is the reason why the node 1 is primary and node 0 is secondary. So, but here you can see here it is primary. Node 0 is primary. Well, I did the failover. That's the reason why you are able to see that. Okay, let's make the redundant group 2 active on node 1. So now you can see here, I have created node 0 as primary for the RG2. Let node 1 be primary for, okay, this is great. So node 1 is primary for RG2 and node 0 is primary for RG1. That means our incoming interface is red 0 and outgoing interface is red 1, which is in different RG groups. So traffic will come from the client to the node 0, and then from the fabric port it gets to SRX2 and then goes out to the server via the red interface. So let me show you. So when I do this, the ping is going out where, so you can see here it is coming on to red 0, going out where red 1. Our red 1 is active on RG2, which is primary on node 1. And I'm going to show you, if I do the failover of the node, is not going to affect my traffic. Would be a matter of single ping loss. You can see here node 1 is primary. I'm going to make node 0 as primary. You can see here node 1 is now secondary, node 0 is primary. And the same thing I can do it for the redundant group 1. Right now 1 is having node 0 as primary. I can make node 1 as active. You know, I'll tell you the flow, what will happen if I do this. You can see here node 1 is primary for RG group 1. So what it is going to do is the client will send the traffic. It is going to come to the node 1 because red 0 is in RG1. And then from here, the exit interface is red 1, which is in group 2. And for group 2, node 0 is primary. So again, the fabric port will send the traffic to node 0 and it will send the traffic out. But then I can change the flow if I go ahead and do the setting as like node 1, you should be active or you should be primary. So what it is going to do is it is going to make node 1 as primary for both the RG groups. So the traffic will come directly from client to the red interface, and the red interface is, you know, active on RG group 1. It is going to go here, and then from here, exit interface is red 1. Red 1 is in RG group 2. RG group 2 is active on node 1 itself, so it is going to go this way. Well, this is how you can do the load balancing on SRX with chassis cluster. I hope I have explained all the terminologies here and how to do the deployment. Well, if you have any question, you can post it in comment section, and I'll be happy to answer all the questions that you have. Thank you guys for your time, and please do subscribe to my channel so that you get the latest update whenever I upload any security content. All right, guys, have a good day. Bye bye.